set that I was supposed to go through. So obviously, with an hour about to go, maybe. Well, yeah, 52 minutes now. Your first reaction would be when you get one of those messages from your boss, you're like, oh, this is fine. It'll be okay. I'll just tell him it was late. But luckily, it's okay because there's this awesome up and coming open source project called Charmed HPC. So looking on the screen here, it kind of involves various components that are worked on and maintained by Canonical in the community. So first we have LXD. That's kind of what provides the cloud for our HPC cluster. And then next we have kind of on the left here, on the far left, we have Juju, which is the orchestrator that we use to deploy our HPC cluster. And then right in the center there, you see that atom. That's kind of what represents the community project that is the HPC clusters that are deployed using Juju. So you might be asking yourself, how do we use a Charmed HPC cluster to solve our problem? With our problem specifically being that I waited until the last minute to analyze the data set that was requested by my boss. So how many people are planning on following along here? Raise hands. All right, sweet. So we have these commands here. What we're going to do is we're going to basically install the backing cloud. Then we're going to initialize it, make some profile modifications to LXD, mostly to make the shared file system work. And then after that, we're going to install Juju, and then we're going to bootstrap our cloud. So let me exit out of here. See if I can make this a little bigger. Oh, you use Chrome. Okay. Let's see if this works. There. So I'll try and make the commands just a little bit more visible. So here now we have a terminal. Sorry if the text is small. I'll kind of work through it with you here. Sorry. All right. Okay, is that text like big enough? Can you see it in the back, or do you need a little bit bigger? I'm seeing kind of a puzzle face. Can I get a thumbs up, thumbs down? Yes. Is it good or okay? All right, thank you. So first things first, what we're going to do here is we're just going to go ahead and install LXD. Oop. Oop. LXD is already installed, but you'll want to go ahead and do that. I'm working off a computer that I don't normally use. And the next thing, is it okay if I run init auto on LXD? All right, sweet. I'll do it again. So then we'll do LXD. Okay, so we've initialized it. Next thing we're going to do here is we're going to set the profile modification. I heard that. Okay, set default. What? Are you using bash? Oh, there we go. Okay. There's an extra space there. That was the problem. So then what we're going to do here is we're just going to modify the privileges of the instance. Make sure I spell privileged right. Privileged, true. There we go. And now what we're going to do is we just need to modify the AppArmor rules. And so the particular reason why we're doing this here is that in the Charmed HPC cluster, we're going to use NFS. And so by default, using NFS, you can't really mount inside of LXD system containers, mostly just because of some permissions issues at the kernel level with mounting NFS file systems. So by modifying the profile here, essentially what we're doing is that we are telling LXD, hey, allow NFS mounts to come on through so that when we deploy our cluster, we can successfully mount our shared file system across all of our nodes, specifically the control service and the compute service. So that's why I'm doing that here. And then just have a little bit longer one here. But essentially what we're doing is that we're modifying the AppArmor rules to allow the NFS mount type through. Okay, set default. And then we'll say raw.appArmor. Okay, making sure I'm spelling everything right. All right, and then we'll go to a new line here, and then we'll say mount, and then file system type equals NFS. And then the star character here is so that we can allow like multiple protocol versions. So you'll have like NFS v3, and then you'll have NFS v4. By using that star, we basically say, okay, you can pass all kinds of NFS through. And then we'll just add a nice little comma here, and then we'll say mount, and then file system type. And then got cut off here, so I'll move it just a bit. And then it's just RPC pipe FS. Oh, will it fit? Yes, it does. Nice. So we'll go ahead and run that. There we are. Move this back over. And then the next thing that we're going to do is we're going to go ahead and install Juju. So we'll do sudo snap install Juju. And we'll see that Juju's already installed because I'm on my boss's machine here. So you go ahead and follow that. And then the next thing that we'll do is Juju bootstrap localhost. Hopefully that works. You have Juju 3, right? Ah. Critical. Huh? Configure LXD, new group, LXD. Is that okay if I run that? Okay. Why did it do that? Okay. Strictly confined microcates. Are you using like Juju 3.0? Snap info Juju. Okay. Sorry if I'm outing you here. Juju. And then we'll go channel equals. Sorry, bear with me here. Local snap Juju. Okay. Works on my machine. Yay. Okay. You're on the Summit network, right? Yeah, you are. All right. Okay, so do I still have you all with me here right now? Anybody have any questions? Figure kind of ad lib a bit while we get 380 kilobytes per second. So that's a good question. What operating system are you using? Yes, using Mantic Minotaur. Yes.
What's the rest of the NXT profiles that default for
Oh, yeah, I can help that. How do I hide that? Okay, I'll hide that. Is that better? Okay, sweet. Yeah, so once again, like I said, just to make NFS work through LXD, you just have to modify the default profile so that allows the mounts through. But I will say the network was a lot faster earlier today. So I'm thinking of some. I guess you could say when the network is slow, aw, snap. I heard some laughs. That makes me feel better. But we're almost there. Yes.
Things work in a Docker container sort because I tried it, but obviously because
So specifically on Docker container, probably not. If you're using like a system container with like, say LXD, for example, then you could follow along there because it mostly just needs the systemd for the snap components. Yes. Yeah, we are on canonical Wi-Fi. Yeah. I mean, we could try the Summit Wi-Fi, but we're at 80%. I don't want to cut it off. Speeding up. There we go. Hey, we're almost there. All right, it worked. Yay. So now that we have Juju 3.1 installed, we can just go ahead and do the final bootstrap. Oop. Juju bootstrap localhost. So what this will do here is that this will set up Juju to use our local LXD installation that we just installed. Basically, what it will do is that it will set up a controller, the Juju controller, and then that's how, when we execute Juju commands kind of further down in the workshop here, it will communicate with that to direct the LXD cloud. So there we go. Now it should work. So as you can see here, it's bootstrapping localhost. The agent version is 3.16. I believe that's the latest release of the 3.1 channel. And so now what we're going to do here is we're going to download the specialized LXD instance for our control node here. So hopefully it goes a little bit faster. Yeah, it's pretty good speed now. Yes. So specifically with the snap that I'll be using later on in the tutorial, it's only set up to work with AMD64, but it won't be too difficult to like enable support for ARM64. It's just mostly producing the images to use it. Yeah. Does that help? Okay. Are you on ARM64? Yeah. Yeah. So ARM can definitely be. I just need to build it, but yeah, it should work pretty easily. You can just compile across, the work can be done. It's kind of waiting in suspense, for the image to come down. But I guess that's what you call conference Wi-Fi. You can do it. So how's everyone's day going so far? You having fun at the summit? Just making small talk. I feel a little awkward standing up here. I'm not going to do that. But yeah, it's just like, trust me, I know what I'm doing. It's the internet. That's the problem, not me. All right, so now that it's downloaded the image, essentially what it's doing here now is that it's setting up the Juju agent, and it's just kind of running some base machine configuration to set up the controller instance. So it's attempting to connect, make sure that the connectivity to the controller is good. And then now it's just running a provisioning script that will finish the setup of the machine. And then once that's done, we can kind of continue on to the next step. It's very exciting. Yeah. So while this is finishing configuring, why don't I move on to the next part here, just so we can kind of get started. Oop, there we go. So step 2 is to actually deploy said minified HPC cluster. I actually have 3 commands here, so it's pretty simple to set up. Essentially, I have this edge snap called Pluto, which is effectively a wrapper script written in Python that kind of handles a lot of the cloud setup for you. Essentially, you can look at it this way as I'm saving you the manual effort of setting up, Terraform files to go ahead and deploy all your Charmed operators, and rather have it automated using this script. So, kind of in the basis of time here, what I'm going to do is I'm going to open this second tab here while our machine is configuring. Can everyone read that? Is that good enough size for you all? Thanks, James. Thanks. All right, so now what we're going to do is we're just going to go ahead and install Pluto. Very minimal snap, just effectively wraps Juju. So we'll go ahead and say sudo snap install Pluto Edge. And then the reason why we're doing Edge is because, I kind of continuously iterate. And that way I don't want to, make a stable release and promise people that like, oh yeah, it's not going to change. Hey, Billy. All right, there we go. And as you can see, the snap is a lot smaller, so it downloads much quicker, which is nice. All right, so we'll go ahead and do that. And as you can see now, Pluto has been installed. And next thing that we're going to do here, just to make Pluto aware of Juju so that it can actually communicate with the CLI program, is we're actually going to connect the snap interfaces. So essentially, Juju will provide the Juju binaries, and then using sudo snap connect, what I'm going to do is basically tell Pluto, hey, this is where you can find the binaries for this specific version of Juju. So hopefully I don't need the password again, but we'll do sudo snap connect, go to a new line here, Pluto. And in this case, the interface is just called Juju bin. Then we'll go Juju here, and then we'll connect to the Juju bin interface provided by the Juju snap. So we'll enter that, and then here you go. So you'll see the plug is connected, very quick, nice and simple. So now we'll go pop back over to this tab, and we'll make sure that Juju is running. So now you can see here, kind of at the bottom, see if I can maybe, oops, sorry. I'm not used to this machine. As you can see, kind of at the bottom of the terminal here, maybe if you look through the crowd, it's kind of like at table level. So it might not be optimal for people in the back, but Juju is fully set up now on the system here. It's connected to work with the local LXD cluster that I have running on the system. And now what it's telling me is that like, hey, you're good to go. You can start adding models and deploying Charmed operators. So what I'm going to do now is just make sure that this instance or like this terminal window is aware of Pluto. So you'll see here, path sudo snap bin Pluto, clear the page here. And then what we're going to do is just execute one really simple command. Pluto bootstrap. And then kind of what's not on the slide here, but I want to show you is I can actually set how many compute nodes that I want to have. So that's basically where our workloads will run. I'll just do Pluto bootstrap -n1. And then I'll give the cluster the name Charmed HPC. So provided everything goes well. Oh, how'd that happen? I'll just make sure I might have spelled something wrong here. Yeah, I'll ask the developer of the package. I wonder who he is. Okay, I used the wrong flag. That was the problem. I'm very used to n being number, but I realized that I want it to be different and called it compute. So clear the page again here. I'll do that. So you'll see Pluto, Bootstrap, and then compute. That's just one compute node, and then kind of a little cut off there, but the cluster's name is going to be Charmed HPC. So we'll go ahead and run that. So you see here, deploying cluster Charmed HPC. This will take several minutes. It takes a few minutes to set up the cluster. So the first thing that's happening is that it's actually deploying the core HPC services. Quick poll of the room. How many people are familiar with like supercomputers, like in the software they use, kind of traditional batch scheduling systems? One person. All right, sweet. Okay. So essentially, what these HPC services are the shared file system. So in this case, we're using NFS. And the way we're using the shared file system is that we're mounting it across all the nodes in our cluster that we want to make aware of, like the data that we're going to use in our workloads. And so that way, depending on the next component, the resource scheduler, wherever it decides to put our workflow as the host where it's going to run, that workflow can then see that data and kind of consume it when it's doing the calculations and analysis and all that. So as you can see here, it's provisioning the NFS server. And then kind of what you'll see later on in the dialog here is it will then provision the identity management. So you can kind of think like, you know, you're your user on your laptop, pretty simple. But in HPC systems, they can commonly have up to thousands of users. So you need an efficient way to do that. So in this case, we'll be using LDAP to provide our users. So we'll provision that, set up a basic default user that we can log into and run our workloads. So while that's deploying, I'll pop over here and I will show you kind of a Juju status bin. So I'll embiggen this. And then what I'm going to do is run the command watch C, Juju status color. Pardon me. I got to switch to the model. So I'll go Juju switch Charmed HPC. All right. And so then what you're essentially looking at here is kind of the overall status window of every unit. So what you can see here is that we have compute. What this compute node is essentially is that it is where we run workloads. So you can kind of think like, all right, you know, if you're doing like Inkscape, doing some mathematic calculations with Python, that's where that would run. And then we have this node here called GeoAuth, which is our LDAP provider in this instance. So GeoAuth is kind of nice because it can integrate with backends such as like MySQL and Postgres. So if you wanted to add users to your cluster, you would just make SQL queries. But since we're running a very minimalized version on this laptop here, we're just using GeoAuth itself and the configuration file format that it provides. And then here we have our NFS server. What this is the NFS server, pretty straightforward. And then part of that you'll notice is that we have a home NFS proxy. So this operator that you see here is what's responsible for making our cluster aware of said NFS proxy. And then as you can see, it's --home. So what that name signifies is that we're exporting our cluster's home directory. So basically, if I log into a user, go into like home/username, that's going to be the same across every node where we have that NFS share mounted. And then here, what we have is Slurm database. So for our cluster here, we're using the Slurm workload manager. Essentially, it's has its own like batch file format. And when you want to run jobs, essentially you just type a command called sbatch with your job file that you want to run, and Slurm takes care of kind of figuring out where on the system it wants to run. So the role that Slurm database plays is that it kind of serves as the accounting. So if I wanted to see like, okay, what's the general overall usage on our system, Slurm database would be responsible for kind of proxying that information into this MySQL unit that you see here. Then there's Slurm REST API. Pretty straightforward, just provides a REST API for working with the Slurm workload manager. And then we have Slurm controller, this is the unit that's primarily responsible for kind of handling the workload scheduling. And it'll go out, see, okay, what's the best compute node for deploying this? And then it talks with compute for scheduling. So now if I put this window back over here, and then this is just kind of a basic visualization. How do I re-enter presentation mode? Okay, we'll try that. Hey. So yeah, so this is just kind of a visualization of where everything's going to go. So we have a MySQL router that kind of handles the communication with MySQL, so that if we want to have like a highly available database accounting or accounting database solution, the router would be responsible for kind of facilitating which MySQL instance it would contact. And then if you see the REST API here, this kind of would function as the front end if you're coming in over the web. We're going to kind of be using a more traditional model where we log into a head node. So our head node in this case will be Slurm CTLD. That's the name of the control daemon that's running using systemd. And we'll go there and then use, as you can kind of see here, Slurm CTLD is largely responsible for communicating with the compute nodes, otherwise known as slurmd, which is the compute daemon. And then if you go over kind of to the right side, or no, the left side in this case, it's right on my side, you'll see the NFS proxy, the NFS server, and then just geolof. So, and then these little gray boxes here, what these symbolize is kind of like subordinate, or if you're kind of familiar with Kubernetes terminology like sidecars, so they kind of extend the feature set of the unit. In this case, what TripleSD is doing is that it's taking the users from geolof and making the NFS server aware of it, so that when we create files or we run jobs, the NFS server kind of knows about our users. And then in the resource management, kind of same thing, being aware of users. And then we have NFS client, which facilitates mounting the NFS share. And then over here, the MySQL router just handles communicating with the MySQL instance. So a few moments later, this is kind of the slide for as we wait for the cluster to finish deploying. But at this point, I just wanted to pause and say, does anyone have any questions? Anything of that nature? Okay, that's good. No questions. All right, that's great. So I'm just gonna zoom out of this real quick. See how it's going. Oop. I'm gonna close that. There we go. So yeah, we can just kind of sit here and wait for it to finish deploying. So as you can see here, when units reach the status active, what that means is that it's now fully deployed. That's just kind of a good signifier to us that like, okay, whatever provisioning tasks that need to be done are now wrapped up. So as you can see here, kind of where units are blocked, essentially what's happening is that they are waiting to kind of get information from one unit from another. So for example, the compute operator is waiting for the Slurm controller to kind of become active and share its information so that it can start itself. Okay. So as you'll see here, kind of then giving another update is that Pluto has actually finished deploying the Charmed HPC cluster. And then what this status message essentially says is just give it a minute. So Juju, by default, is asynchronous in nature. That way you don't kind of have to sit and wait forever. So in this case, what we're doing is we're just waiting for our cluster to finish deploying, which it looks like it's almost there. So it's just waiting for an NFS share. And now, as you can see, active is available on every node now. So that means that our cluster is fully deployed. Okay. I think that's a good sign. Okay, so now what's going to happen is that we're actually going to go ahead for step 3, which is we're going to run said workload on our cluster. So essentially what's going to happen here is that you first see a Juju exec call. What this is doing is that it's just installing some dependencies that we need for our workload. This is still kind of an experience that we're working on fine-tuning within Charmed HPC so that you don't have to kind of use these raw Juju interfaces to be able to deploy dependencies that you need for your workloads. And then the next command, what we're going to do is we're going to actually SSH into the controller that will be functioning as our head node in this case. And then on the third command here, we are going to log in as the base user that we provision in GLauth. And then this part here is just essentially running the workload. So now, minimize that. Now what we're going to do is that since it's deployed, I'm going to do the Juju exec call. So when I do the pass-a, essentially what that's saying is application. So in Juju, there's basic terminology where there's units and applications. Applications kind of, as I like to think of it, represent, I have Heather looking at me, I feel nervous now, but what is it? Applications, they kind of include all the units so that when you want to refer to, like, let's say you have 200 compute nodes. If you want to speak to an individual unit, you would use -u, but if you wanted to speak to all of the compute nodes at once, you would use -a, saying like, communicate with the compute application. Oh, that's going to cut off, isn't it? Dang it. It just wraps? Okay. But wrapping bothers me. Okay. Then we're just going to use apt-get, since app doesn't have a stable CLI and I don't want it to yell at me. And then we'll just bring in some bare essential packages that we need. So we'll just do build essential to get like GCC. And we'll just do Python 3 dev, which just provides like the development header libraries for Python. And then we'll just do Python 3-venv. And what this does is it just brings in venv so that we can create individualized environments for our workload. So I'll go ahead and run that. Everything should go. It'll just take a few seconds to complete here, potentially a minute, depending on the network speed, because it's installing these packages on every node where we need it to be. So we'll go ahead and wait for that, and we'll go ahead and get started. You know, we still got 20 minutes left here, so I think, yes, Billy.
I was just curious. I still need that report. How's that going?
Well, aside from hardware issues, the software is pretty fine. But yeah, so it'll essentially, this task is synchronous here, so we'll wait for it to finish running. There it is, you know, I guessed myself. But as you can see here, it just sets up the things that we need. So like GCC, C++, libc, TIFF for some reason, zlib, all that good stuff. So now, let me clean that, and we're going to go inside our Slurm controller. -leader, and essentially what this says is go into the, you know, control node that's in charge of all the other control nodes. So log in. There we go. Now we are going to log in as our researcher. So in this case, I got the very inventive name researcher. Log in, so that's how we know that our LDAP is working here. Then the next thing we're going to do is we're going to git clone the repository that we need that contains our workload. So here, and I hate typing out URLs, but it works. GitHub.com. That's Nucci the boss. And since it's a URL, you can keep it all lowercase. And then last minute analysis.git. Wonder why it's called a last minute. God, that still messes with me. Okay, so we'll go ahead and clone that. It's receiving the objects. And then this Git repository contains the data set that we have, so you don't need to fetch it manually from anywhere. Next thing that we'll do is we'll just change into that directory. Oops, let me clear the page again so the people in back can see. Last minute analysis, tab complete. Oh, that makes a nice, beautiful long path. And the next thing we'll do here is we will set up a virtual environment, Python 3 virtual environment, and that will just provide where we will do the pip install and all that so that we don't have to create system packages. And I'm just going to activate that in the same command. So we'll do venv -bin/activate. So it just takes a few seconds for that to finish as well. There we go. So now the path is really long. But as you can see here, we are now inside that active Python environment. And then I essentially just took care of installing the requirements for you. So just in this requirements.txt file, it just contains some basic dependencies. So like click for the CLI components, matplot for rendering graphs, and then numpy for mathematics. We'll go ahead and exit out of that. And then I'm going to just install those dependencies real quick. Pip install -r. I just recently read a blog post that says that you're not supposed to use requirements.txt anymore, but I like it, so I used it. All the cool kids these days use a PyProject TOML if you're a Python developer. At least I think they do. I still like setup.py for anybody that's out there. Most standard?
It's the new standard.
It's the PyProject TOML. So it's just going ahead and installing the packages that we need here, pretty quick downloads. So in this NumPy, essentially what it's doing is that it provides the calculations. Once we finish installing, I'll just kind of go through the job file that we have real quick, and then we'll go ahead and actually submit our workflow. The suspense. All right, there we go. So now we have our requirements installed. The next thing that we can go ahead and do is we can actually go ahead and submit our job. So now, what does our job actually look like? Well, I also included the submission script that we're going to be using here. In that case, I was actually prepared in advance, but let's call it batch, which signifies that this is a batch job. So we're just going to submit it off, and we don't care about it being like synchronous or waiting for it to complete. I'll enter here. So what you can see, just kind of going through the output real quick. Let me maximize this window so it's a little easier to read. But if I scroll up, the first thing you'll see is the hashbang bin bash. What that is that it says this is a bash script. So with Slurm, you can submit any kind of shell script, really. So you could do like C shell, Thompson shell, Z shell, if you really wanted to. So I just use the generic name batch and then just specify which shell I want at the top. And then here, what you'll see is a couple of parameters or directives. What these directives do is that they tell Slurm kind of the resources that we're looking for on our system. So in this case, we say we just want one compute node, and then just allot it 1 gigabit or gigabyte of memory, and then just how long the job should take. So in this case, I've set it to take an hour, and then just where to store the standard out and standard error in case any is emitted while the job is running on the node that we don't have access to. And then we just give it a name analysis so that it's easier to identify it in the queue. Typically, it won't matter if your HPC cluster is only you're the only user on it. But if you're on a system where there's like potentially 4,000 jobs running at once, job name feature is very helpful for figuring out which one is yours. So now I'm kind of paging through this. Essentially what's happening here is first, we're changing into where we submitted the job from. So that's kind of where I have the data. Then activating the virtual environment that I created. And here is just a couple of Python scripts. They're not too terribly interesting, but it just helps us process the data. And then the analysis is what analyzes the XML files that are created that contains the data. And then this here is some beautiful XML manipulation where I'm just using TAC to basically add a root tag to all of the files. And then down here is where I'm just generating the graphs for the data that I'm analyzing. And then lastly, I'm just kind of doing some cleanup and creating the output for the analysis that I have. Just making a simple tar file that contains a couple of PNG files that we can then view later on. So here, reshrinking the window a bit, we'll have our workflow. First thing I'm going to do, though, is just, what the hell happened there? Okay. What I'm going to do is just make sure that my Slurm cluster is up. State invalid. That's not good. Give me a second. Just going to make sure everything is okay with the compute node real quick. All right. Everything should be fine. So I'm going to go ahead and submit here, and hopefully that works. No names. Socket error. So if you do the SBatch, if your slurmd instance is running well, you should be able to see a tar.gz file. I'm going to take a look here, see what's up. This is also the fun part of a workshop, is debugging. Okay, next thing I'm going to try here real quick is the old reliable. Did you try rebooting it? Okay, so it looks like everything's good now. All right. Oh, no, that's my own fault. Error, node names, CPUs, match no sockets. Okay, gonna do a fun little thing here. I remember the command, slurmd help. Force cleanup, report, print node configuration. There we go. Looks like it got a little confused on itself by accident. So we'll go ahead and copy that. Generally, Pluto will fully deploy it, but I think there was an issue configuring the configuration file. So we'll go ahead and log in there. And then Slurm has a pretty nice configuration format. We'll just edit it real quick. Let me clear the page. We're going through debugging together. This is a day in the life of a HPC engineer, unfortunately, if anyone was curious. Oop. So this here, what you're looking at is just the configuration information. So this will just specify a couple of nitty-gritty Slurm details, like where is slurmd running, where is slurmctld running, PIDs specifically for like the systemd service. Some more information like where to send the accounting information, slurmdbd, resource types. There we go. And then basically what I'm going to do here, since I'm editing, is I'm going to pull this line out. And then put in the real configuration information that we have for our slurm conf file. And then I'm just going to get rid of this real quick. And Control S, X, out. And then real quickly, I'm just going to restart the slurmctld daemon. Or let me restart slurmd real quick. We still have 7 minutes here, so we're in the clear. Yes, I'm sure. I take that as a challenge. Thank you very much. So we'll restart it here. It just takes a little bit because essentially what happened to make it work with Jujuism is that we actually modified, or at least I modified, the systemctl service file where it's like kind of a simple daemon to a forking type. So I have a specialized Python process that is focused on starting slurmd. So you'll see here, there we go. It started slurmd. That way, slurmd status. Hey, there you go. And then I'll restart slurmctld, give it the latest state. Parsing error, unrecognized key, uptime. All right, I'll fix that real quick. Jesus, man. Getting like 11th hour here, but trust me, we can do it. I forgot that uptime is not a valid key, so you probably shouldn't copy that in, but don't do what I do. Let's put it that way. There. Okay, we'll save. Exit out of that. And then I probably gotta. There we go. Are we having fun here? Yeah, 5 minutes left. In 5 minutes, I bet we can do this. We can do it. I'm very optimistic. I'm feeling good about this one. Okay. I realized just now that I could have patched the -- now flag and that would have made it not hang. But hindsight, retrospect, hindsight 2020 vision. But all right, we should be good now, hopefully. Since I removed the. Hey, now it's running. And then if we do SBET or SInfo. What do you mean it's down? Jesus, man. All right, we got 4 minutes left. Can we do it? I might ask them not to post this recording. Ah, I'm embarrassed now. State up. See, can I do state up here? Right, I'm on this node, so why is it down? See if I can say state up here. Maybe not, but we'll try. Okay, let's see if it works this time. We got 3 minutes left. We can do it. Oh, what are you? Oh, it's probably saying that's not a valid flag. I know it. I know it. Valid state up? What? As you can tell, HPC clusters are very finicky, unfortunately. I'm just going to go ahead and say it works on my machine. I think that's how I'm going to make myself feel better here. Okay. What? Oh, don't remind me. Okay. Why are you down? Makes no sense to me, man. Restart you again. Yeah. Yeah. I just don't remember the command off the top of my head. Maybe I tried to restart it too soon. I should have waited. I should have been patient.
Update that node name equals have the node name. Save.
All right. Okay. I'll just try and restart it one more time, and then we'll try that. Okay, so it started now. Let's retry. Okay, so that's running. All right, S control. Okay.
Node name equals.
Yeah, I got the node name here.
State equals.
Okay. And then, yep. Thank you. This is why it's this workshop, because we work together. Oh, God. I'm going to hear about this later. To get a meeting invite on my calendar, be like, state of HPC. I know that's it for me. All right, so now that we got some good vibes going now, we're going to go back in the bin. Wait, I don't even need to activate this now. We're just going to do spatch. And then, let me clear it so people in the back can see. Submitted batch job 2. Now it's suspense, waiting for it to be done. So we'll do SQ. Fortunately, that report's going to be late. Sorry, Billy.
Good boss. I actually told you it's due today. It's not tomorrow.
All right, so as you can see here, the information's empty. You might be saying, why? Well, that's probably because our job is finished. So if you look here, you'll see a bunch of new files have been created. So like analysis output, TGZ, that's just a tar file, analysis.out, and then analysis.error. So for any captured standard error messages, if I go into analysis.out, here we go. You'll see it only took like seven seconds to complete. So that's pretty good. So now what we're going to do is I'm just going to copy this to temp real quick. I shouldn't have written it that way. And then copy that to temp. I'm going to log out of the node here. And what I'm going to do, why is your host name orange, by the way?
All my computers are named after hosts.
Oh, that's cool. Mine are all named after Godzilla. You would have seen that if my HDMI was working correctly. Then we'll just copy down the file here using Juju SCP. And thank you for bearing with me, by the way. I appreciate that. Okay. Then you'll see if we unzip. If I change into analysis output, yay, you'll see that. I'll do that again just so people can see. You'll see, yay, we have all the analysis files. So if I open the file explorer, is it okay if I do that? I'm just making sure, I don't know. I don't want to accidentally click on your AWS keys or something, And then, ta-da, you'll see that we analyzed the data in our HPC cluster. Just took a little TLC, but usually it works. It creates a good experience. But yeah, so I should have remembered S control. All right, so you'll see here, we kind of went through all the commands there, but that's typically the workflow that you would follow. I just copied the temp mostly because any data, make sure it's not corrupted or anything like that. And then I just SVP it out using the Slurm controller. So typically for like HPC systems, once you have like data files, you would download them off the system, and then that way you can kind of redistribute it at your leisure. So now, ta-da, that's what everything should look like. A little less on Rails than I'm used to, but I'm just going to say it works on my machine. And yeah, there we go. So Congratulations, you deployed a minified supercomputer on your laptop that should have hopefully worked correctly. If not, you can either restart the daemon using systemd, or you can use the scontrol command, which once again, thank you for typing that out for me, because I remember scontrol, but it's like, I always forget like the specific syntax. So thank you again. But yes, so with that, as you can see, we had very alpha experience of what we're kind of hoping to do using Juju LXD and kind of Charmed HPC. So if you are interested in the project and kind of like what you saw here and potentially have ideas for improvement and whatnot, I do want to say that our community is open for contributions. So is the project. So you can just scan that QR code there, navigate to the URL on the bottom of the slide, kind of pull up more information about the HPC community team and what we do and how you can get involved. So thank you. All right, any questions? Okay, I guess I did a good job. Oh, just one.
You didn't get it.
It's a microphone. So yeah, so for anybody that didn't hear, the question for the room was basically what exactly is Juju? The way I like to describe it is that it's kind of like a cloud orchestrator. So if you've ever worked with something, say like Ansible or Puppet or Chef, it's kind of like that. But I like to say that Juju kind of goes the next level above, where the applications that you deploy are more or less self-driven, and essentially using integrations and events, the units that you deploy are able to kind of communicate back and forth with each other so that you don't have to do the nitty-gritty configuration. Does that kind of answer your question?
I think so. So if I understand correctly, you're using Juju just to install everything. It's kind of like a Puppet or something like
Yeah,
that.
yeah.
Yeah, but basically you're using the Slurm as a scheduler on HPC. So you're just providing some configuration to Juju to install the entire cluster here.
Yeah,
Okay.
yeah. So we use Juju to deploy kind of the units, and there will be individualized units for like each of the core Slurm services, like the compute daemon, the Slurm CTL or controller daemon, the database and all that. And then what Juju kind of facilitates is the configuration of the entire Slurm cluster. So for example, Juju will, when it deploys, like say like Slurm controller or the Slurm controller, it can like integrate with the Slurm compute daemons so that when it comes time to turn on the nodes or basically mark them as up or active, it handles exchanging the information that's required for Slurm to be able to successfully communicate with Slurm controller, and then kind of the opposite way around, where it enables or it makes the Slurm controller aware of like all the compute nodes that are available in the cluster. Yes.
Just another question. How does the configuration file for the Juju looks like? Because you actually was simply installing all the packages, but actually I haven't seen the part with configuration.
Yeah, yeah. So kind of what Juju uses is these operators. They're called Charmed operators, and what they are like collection. It's like collections of like Python scripts, and basically to create a Charmed operator, you use something called the operator framework. It's developed and maintained by Canonical in the Juju community. And through that, you kind of are then able to develop those applications. So you could basically create like your own custom events, like, oh, when is something installed? When is something turned on? And then the idea of using that framework then is that you can facilitate the communication between your services and also kind of create events that they can react to. So for example, I could say like, hey, this compute node just sent over its configuration information. And then what Juju will do is it will emit event that tells the Slurm controller like, hey, you have new configuration, kind of walk through or run this Python script that facilitates that configuration of adding it to the Slurm conf file.
Thanks.
Yeah. Yes.
How big was the data set that you were processing, and what would be the difference between doing with HPC and non-HPC?
Yeah, so the data set that I was using is pretty small, mostly just because we're running on a laptop. But typically it's like you're looking, when you're running on HPC systems, you're very much looking at like multi-terabyte like data sets. And then kind of why the HPC system is nice is because you might have a collection of people that are all running their very own like analysis on that set data. So typically that paradigm is called like many task computing. So in that situation, you just have like a lot of independently running jobs, and you need the HPC system to kind of facilitate access to those resources so that people don't accidentally step on each other's toes or run the system out of available resources. But yeah, in this case, we're using a very simple setup. So theoretically, you could just run the Python script directly on your laptop and be fine. But it wouldn't be very fun if you didn't set up an HPC system to handle it for you, as I like to put it. Great question.
Hello. Why use Pluto to drive Juju? Why couldn't you just deploy Charmed HPC with a bundle?
That's a good question. So right now, you need a little bit more kind of manual push. So Pluto's doing a few things under the cover. So in an ideal experience, essentially, you would just write like your Terraform bundle or YAML bundle, and then specify all the configuration options, integrations, and whatnot that you want to deploy. But with Pluto, it kind of handles some of the bits that you would usually be expected to manually set up. So for example, like the NFS server, we're using an NFS server or kernel server as kind of like the example implementation, but there isn't like a Charmed operator for that. So Pluto handles like the manual provisioning of that. But ideally, usually somebody would like deploy a Charmed HPC cluster in AWS, GCP, Azure, where you're probably proxying in like a file system solution that cloud offers. But in our case, since we're running on the laptop, we need to set up our own. So that's kind of what Pluto helps with. And you can't really code that behavior into like a bundle file. Does that answer your question?
Yeah.
Okay, sweet. Thank you. Great questions. Any more? All right, with that, let's party, because I did.